Okay, so this is our forest carbon project. This is the first plot that we installed, and it's here in a shade-tolerant hardwood forest. Carbon is a very, very big word for a lot of things that come with just letting a forest grow. So not only do the trees absorb carbon out of the air, obviously carbon dioxide is pollution nowadays, but it also helps to stabilize the soil and absorb water, provide shade, provide clean air, provide diversity. And so our office, being the first conservation authority in Ontario, to coordinate a forest carbon project. This short video is just to outline exactly where the plots are and when they happen, the inventory that goes with it. So the first thing the technicians do is find the plot center, which is right on the ground behind us here. And the plot center is found completely at random. It is mapped through the GIS software, and dots are placed. There's 300 carbon plots across our 30,000 acres. And they're situated completely at random, and so the carbon plot consultants, forestry consultants, need to actually hike to these plots with a GPS in hand in order to find the plot center. And then once the plot center is established, your typical plot size is 11.3 meters in a circular diameter. And that number relates to 1/10 of a hectare. So it's a very mathematical circular measurement. And within that plot, you can notice that every single tree has numbers written on the side. And that's each individual tree is identified by species, also by height and by diameter, and then given a number, so that we can return to these plots in 10 years' time and do the exact same measurement again and field verify what we can calculate by a computer, by a computer model. These sort of plots have been done other places in North America, and over time they call them growth and yield plots. So we do have a fairly good idea of how the forest, or how quickly a forest will grow, but this will actually verify. Then internal to the larger outside plot, even small trees, being less than 10 centimeters, are also measured, but those are not numbered because they're too small. So these trees hopefully will still exist when the plot sampling staff come back again. The idea is that these plots will remain as is, even if the forest around them is being harvested, this is not a harvest site, by the way. This forest will be just left to grow like most of the 30,000 acres the Conservation Authority owns. We anticipate that carbon will be a better revenue generation than cutting of timber, but also gives us a chance to allow our forest to grow into an older age class, because that's really missing on our landscape. Our forests over time have been typically harvested many times, and a lot of our forest holdings, the Conservation Authority holdings, were purchased because the forest was so over-harvested. It was thought to be the best way to just allow the forest to stabilize, the forest cover to stabilize, and only conduct harvests in very, very minor amount of places. So you can see from the quality of the stems in here, it's a fairly young forest. There isn't a whole lot of large trees, and so the best thing for us to do at this stage is just simply let it grow. Part of our ability to generate revenue from forest carbon is forest certification. So forest certification is very important. Every piece of envelope from a bank that you receive, paper that you receive from a bank, For example, most of the printing paper that you see at Staples or whoever, most of the 2x4s that you see at Home Depot, etc., have a stamp on the side of them saying they're coming from a certified forest. And that's really important, because some of the things that forest certification has forced us to do is modernize our policy for the use of the properties, focus into which properties will be commercially harvested and which won't, and conduct inventories like the forest carbon, so that we have some idea of the wildlife species that utilize these areas, over and above, of course, the forest cover. So has allowed us to establish things like these forest carbon plots, which can be used as permanent sample plots, so that we can come back and monitor the birds and the other wildlife, the trees, of course, the vegetation, and keep an eye on things, new things like new invasive species that right now are not present on this site and hopefully never are, but an early detection system for that sort of problem is a really important thing.